Welcome to the 7th video of the module 3 probability distributions. In this video we are going to discuss the exponential distribution and the problems based on the exponential distributions. The exponential distribution is a random variable x is called as an exponential random variable with the parameter lambda greater than 0 and its PDF is given by fx of x is equal to lambda into e power minus lambda x where x is greater than 0 and it is 0 in otherwise. The corresponding CDF of x is given by fx of x is equal to 1 minus e power minus lambda x when x is greater or equals to 0 and it is 0 when x is less than 0. So the graphical representation of the PDF and CDF for the exponential distribution is, this is the PDF when x, it is a lambda, where x axis it is x and in the y axis it is taken as fx of x. So the curve will be lambda e to the power of minus lambda x. Whereas here in the CDF it is x up to 1 it will be taking and then it will the curve will reach up to the 1 here, that is 1 minus of e to the power of minus lambda x. So it will go in the opposite direction. Mean, variance and standard deviation of the exponential distribution. Let us look into this. From the PDF of exponential distribution, we have fx of x is lambda e power minus lambda x where x is greater than 0 and it is 0 when it is otherwise. For the continuous random variable x, mean is e of x, that is integral from minus infinity to plus infinity xf of x into dx, and that is x into f of x is replaced with lambda e power minus lambda x into dx. That gives lambda integral 0 to infinity x e power minus lambda x into dx. So e of x is given by, on integration by parts, that is UV rule if we apply, then we will get x into integral of e power minus lambda x is given by e power minus lambda x by minus lambda minus 1 into e power minus lambda x by minus lambda the whole square, where the limit is 0 to infinity. On substitution of the limit, we get the upper limit, if we substitute e power minus infinity is 0, and when we substitute the lower limit, again it will be 0 for the first term because x is multiplied, so 0 into anything will be 0. Now for the second term, if we substitute, again it will be 0 because e power minus 0 will be 0 and minus of e to the power of 0 divided by minus lambda the whole square. So we will be getting lambda times of 1 upon lambda square, that is 1 upon lambda. That is the mean e of x. Now let us determine e of x square. So that is given by x square f of x or integral x square into lambda e power minus lambda x into dx. So by taking the lambda outside, we need to integrate this by parts, by Bernoulli's rule. UV integral is given by uv1 minus u dash v2 plus u double dash v3 and so on. So u is taken as x square and v is taken as e to the power of minus lambda x. So x square is u and integral of e power minus lambda x e power minus lambda x by minus lambda. Derivative of x square is 2x and the double integral of this e to the power of minus lambda x will be e power minus lambda x by minus lambda cube square plus derivative of 2x is 2 and e power minus lambda x divided by minus lambda the whole cube. When we substitute the limits 0 to infinity, the first term will become 0 on all the cases and the second term, that is 0 and 0, and here also since x is multiplied it will become 0 again. In the third term what happens is it will be 0 the first when the infinity is substituted for the upper limit it will be 0 and for the lower limit it will be 0, that is e to the power of 0 divided by minus lambda the whole cube, we will get it. So lambda into 2 divided by minus lambda cube. So minus of minus, it will be plus, we get 2 divided by lambda square. And the variance formula is given by e of x square minus e of x the whole square. So 2 by lambda square minus 1 by lambda square, which will be 1 by lambda square. That's the variance. So standard deviation is given by the root of the variance, therefore 1 upon lambda. Problem. The time in hours required to repair a machine is exponentially distributed with the parameter lambda is equal to half. What is the probability that the repair time exceeds 2 hours? If x represents the time to repair the machine, the density function of x is given by f of x is equal to lambda e to the power of minus lambda x, where x is greater or equals to 0. So when we replace the lambda value as half, we get half into e power minus x by 2 when x is greater or equals to 0. So let's consider p of x greater than 2. Then it is equals to limit 2 to infinity of integral f of x into dx, that is lambda e power minus lambda x into dx, where lambda is replaced with half. So it is half e power minus x by 2. When we integrate it, it is half into e power minus x by 2 divided by minus 2. And the limits are substituted as 2 to infinity. When we simplify this, we will be getting 3679. This is the value we are going to get it. Next problem. Assume that the length of a phone call in minutes is an exponential random variable x with a parameter lambda is equal to 1 by 10. If someone arrives at a phone booth just before you arrive, find the probability that you will have to wait less than 5 minutes between 5 to 10 minutes. Given here is lambda is equal to 1 by 10. The PDF of an exponential distribution is given by fx of x, that is lambda e power minus lambda x when x is greater than 0 and 0 and other cases. So when we replace the value of lambda, it gives 1 by 10 e power minus x by 10 when x is greater than 0. Otherwise, it is 0. First question. When p of x is lesser than 5, that means a limit of integral is 0 to 5 f of x into dx. So when we substitute, it is 1 upon 10 into integral 0 to 5 e to the power of minus x by 10 into dx. That is 1 by 10 into e power minus x by 10 divided by minus 1 by 10. A limit is from 0 to 5. When we substitute the upper limit, this 1 by 10 and this 1 by 10 gets cancelled. We get minus of e to the power of minus x by 10. And on substitution of the limits, it is minus e to the power of minus 5 by 10 plus e to the power of 0, which on simplification we get 0.393. Next, between 5 to 10 minutes if you have to wait, how it has to be calculated. That is p of x varying between 5 to 10. So integral from 5 to 10 f of x into dx is equal to 1 by 10 integral 5 to 10 e to the power of minus x by 10 into dx, that is 1 by 10 into e power minus x by 10 divided by minus 1 by 10. The limit is 5 to 10. On substitution of this, we are getting here minus e to the power of x value is 10 here, so it is 10 divided by 10 plus when we substitute the lower limit, here also 1 by 10 and 1 by 10 cancels. When you substitute the lower limit, it is e to the power of minus 5 by 10. That is minus e to the power of minus 1 plus e to the power of minus half, we will get it. This on simplification, we get 0.239. Next problem. Suppose the duration x in minutes of a long distance calls from your home follows an exponential law with the PDF f of x is equal to 1 by 5 into e to the power of minus x by 5 when x is greater or equals to 0 and 0 in other cases. Find p of x greater than 5 and varying between 3 to 6, mean and variance of x. We know that for an exponential distribution, the PDF is given by f of x is equal to lambda e power minus lambda x when x is greater or equals to 0, 0 in other cases. Where mean is 1 by lambda, variance is 1 by lambda square. In the given problem, lambda is given by 1 by 5, mean is 5 and the variance is 25. So p of x greater than 5 if we take integral from 5 to infinity f of x dx, where f of x is given by e power minus x by 5 into dx, and we integrate it e power minus x by 5 by 1 by 5. So this 1 by 5 and 1 by 5 cancels, we get e to the power of minus x by 5. Upper limit is substituted, it will be 0 because e power minus infinity is 0. And when we substitute the lower limit, 5 and 5 cancels, we get e to the power of minus 1. This on simplification we get 0.36788. When it is varying between 3 to 6, just the limits will change from 3 to 6. The integration and other parts will be same. Here also 1 by 5 and 1 by 5 will be cancelled. The limit is from 3 to 6. So it is minus 6 by 5 e to the power of minus 6 by 5 minus e to the power of minus 3 by 5, which on simplification we get 0.5488 minus 0.3012, that is 0.2476. Thank you.